Hi, my name is Milan, and today we're going to be talking about updating the database using Entity Framework Core. We're going to see how we can optimize this and why Entity Framework might not be the best tool for the job in some situations. So stay tuned to find out more. So we're starting out with an empty .NET 6 web API. The first thing that we're going to do is add an entities folder. We want to create entities for our awesome company. So the first entity that we are going to need is going to be obviously the company. So we're going to add it now. We will use file scope namespaces because I like it more starting from .NET 6. We're going to add an integer field for the ID. And we're also going to add a name for our company. All right, that looks good. The other entity that we need is the employee, of course. So let's go ahead and add the employee. We're going to use file scope namespaces in this class also. Let's add the ID. We also need a name for our employee, so we're going to add that. We're going to assign an empty string as the default value. And let's also add another field for the salary of the employee. And this is what we are going to be using in updating the database. You'll see in just a moment. And one last thing that we're going to need is the company ID. This is going to be our foreign key that's going to point to the company's table. Back in the company class, we're going to introduce a nullable datetime field. This is going to be the last salary update date and time in UTC. And we're also going to add a navigation property for the employees. We are going to use this with Entity Framework to configure our relationship, and also so that we can load the employees together with the company when fetching the company from the database. Now we're going to add some NuGet packages that we are going to need. We are going to be using SQL Server, so that's the package that we're going to add. Okay. Another package that we are going to need is the Microsoft Entity Framework Core tools. We're going to need this for managing database migrations from the console. So we are going to go ahead and add that one as well. Now, the next thing that we want to do is add our database context. So let's go ahead and do that. File scope namespace, of course. And our database context is going to inherit from the DB context class coming from Entity Framework Core. And we're going to do two things here. We're first going to add a constructor that's accepting a DB context options argument, and we're going to pass it to the base constructor. And we're also going to override the onModel creating method so that we can configure our two entities, company and employee. So first we're going to configure the company. We're calling model builder entity and specifying the company as the generic argument. And then we're going to write a Lambda method. First, we want to specify that the company entity should be stored in the company's table. And then I want to configure the relationship with the employees. So I do builder.hasMany, and then I specify the employees. Then I say with one because each employee can only have one company. And I go ahead and specify the foreign key, which is the company ID. All right, now I want to configure the employee entity. We're going to say modelbuilder.entity and specify employee as a generic argument. And then we're going to create a Lambda method. Inside of the body of the Lambda, we're going to say builder to table. And here we want employees. And that's all that we need for configuring the employee entity. Now I want to go back to the company configuration. And I want to seed some initial data so that we have something to work with when we start our application. So we're going to say builder.hasData, and I'm going to create a new company with an ID of 1 and the name of awesome company. Now we'll do something similar for the employees. We're using enumerable.range method, which allows us to create a range of integer values. We're starting from the value of 1 and we want 1000 values. Then we are going to chain a call to select, which allows us to access each value from 1 to 1000. And we're going to create a new employee instance, and we're going to enumerate this enumerable. So the ID of the employee will be a number from 1 to 1000. The name is going to be an interpolated string. the salary for everyone is going to start out at 100, and the company ID will be 1 because that's what we set when we were seeding the company. And of course we have to say builder has data and specify the employees. All right, this is looking good. Now what we have to do is configure Entity Framework to connect to our database. So we go back to program.cs, and on the builder we have to call services.addDBContext. We specify our database context that we just created, and we want to configure our database context. We're going to pass in a lambda and say use SQL Server, and we're going to pass in the connection string to our database. All right, now that we have everything in place, we can go ahead and create our database migration. We're going to open up the console and write add migration. I'm going to give it a name, add company and employee, and we press enter. All right, the migration is created. As you can see, there's commands for creating the tables and seeding the data. And now I'm going to update the database. And I'll speed this part up because it's going to take a while to insert all of those records. Now we have everything that we need in the database. We added 1 company and 1,000 employees. So now we're gonna go ahead and do something interesting. I want to create an API endpoint to which I can send a company ID. And in this API endpoint, I want to increase the salary of all the employees by 10%. We're going to use the minimal APIs that came with .NET 6. So I say app.map_put. I'm going to give it a route, which will be increase salaries. And I'm going to pass in an async delegate, which takes in a company ID and a database context. The company ID will come from the query string, and the database context will be resolved from the services. The ASP.NET Runtime is smart enough to figure this out for us, so we don't have to specify anything explicitly. So inside of our delegate, the first thing we want to do is fetch our company from the database using Entity Framework. So we're going to say dbcontext.set, specify company as the generic argument. I also want to include the employees so that they're fetched from the database together with the company. So I add an include statement, and I'm going to say first or default async and specify the condition. I want to get the company with the ID that matches the company ID I got from the API. So if the company is null, we didn't find one in the database, and I want to return a not found result. So I'm going to say return results.notfound, and I'm going to write a descriptive error message. Now I want to iterate over all of the employees in our company. So I'm going to go ahead and do that. I'm going to say company.employees.forEach. And for every employee, I want to increase the salary of that employee by 10%. So I'm going to multiply it by 1.1, which will effectively increase the salary by 10%. Now I also want to update the company. Remember that we added a last salary update property. So I'm going to set it to datetime.utcnow because I want to be updating both the companies and the employees table in the same HTTP call. I call dbcontext save changes async, and then I want to return a result. I'm going to say return results.noContent. All right, everything looks good. I think we can start our API now. It is up and running. All right, let's head over to Postman, where I already created our HTTP request. And let's go ahead and click send. This is going to hit our breakpoint that we added. So I'm going to skip over the query. And as you can see, we loaded the company from the database. And down here in the output window, you can see the SQL query that Entity Framework generated for fetching the company. So moving on, I'm going to skip over the updating of the employees because there's a lot of them. And I'm going to update the company's last salary update. And now we can go ahead and call save changes. Now, take a look at the output window again when I call save changes. And notice what's going on. Entity Framework is going to go ahead and create a lot of update statements. How many is a lot? Well, in this case, it's going to be 1,000 update statements. There's going to be one for each of the employees that we have on the company. Also notice that every update statement does the same thing. It sets the salary to some new value for the employee with a specific ID. Now, why is this a problem? In this case, Entity Framework is going to execute 1000 update statements for the employees and also one update statement for the company. Remember that we also updated the company. So there's going to be 1001 update statements for just increasing the salary by 10%. Now, is there a better way to do this? Well, there is, and I'm going to show you now. I'm going to go ahead and copy our existing endpoint and use it as a base for creating the new one. First, I'll update the route. I'll append SQL to it. I'm going to go ahead and remove the statement for including the employees. And the part that I want to change here is how we update the employee salaries. So instead of using Entity Framework for this, we can do something different. We can write a SQL command that will increase the salary of our employees by 10%. So we're going to say dbcontext.database.execute SQL interpolated async. Now, what this method allows us to do is write our own SQL command, which will execute directly on the database. So we're going to say update employees, which is the table we want to update, set the salary to whatever the salary was before times 1.1, which is a 10% increase. And we're going to add a where statement, which will say where company ID is, and we're going to pass in the ID of the company that we fetched using Entity Framework. And the rest of the method remains the same. This endpoint now behaves the same as our previous one. So let's head over to Postman, where we're going to call our endpoint again. We fetch the company from the database, and now pay attention what happens. When we get to our SQL command, when I execute this line, notice that in the output window it's going to output the SQL statement that we just wrote. And now if we move on and execute the save changes call, it's also going to generate the SQL for updating the company. So we have two SQL statements this time, as opposed to 1001 that we had previously. So this is a massive improvement. Now, there is one small issue that I want to show you. Let's go ahead to SQL Server Management Studio. I'm going to select all of the employees, and notice that at this point in time, they all have the same salary, which is 133. Now I'm going to go back to Postman and hit our endpoint again. We fetch the company, we execute our update statement, and now I go back to SQL Server and execute the select statement again. And notice that this time the salary is updated. It says 146, but we didn't still call save changes. So our update statement executes regardless of the save changes call, and this can be a problem. Imagine if we executed the update statement and it works, and then we go to save changes, and for some reason it crashes. But the previous update already went to the database and completed successfully. So now we have a problem. Our database is not in a consistent state. So how can we go about and fix this? Luckily, it's not that complicated. All we need is just to wrap everything that should execute together into one database transaction. So we're going to say dbcontext.database.begin transaction, and this will start our transaction. And after we have completed all of the updates that we want to do, we go ahead and call dbcontext.database.commit transaction. And this will complete our transaction and save all of the updates to the database. So let's start out the application again. We're back in SQL Server. You can see that the salaries are now 146. We're calling on our endpoint again, and pay attention this time what happens. So we're fetching the company from the database. We are now starting our transaction. We are executing the update statement for increasing the salaries. Now let's hop on over to SQL Server again and see what's going on here. If we select all of the values again, we can see that they're still the same as before. It still says 146. Again, if we call save changes and go back to SQL Server and select all of the values again, they're still 146. It is only after we call commit transaction that we can see the changes applied to the database. In this way, we ensure that all of the updates are running in the same transaction, and this can protect us from unexpected database failures. So I want to show you a bonus implementation, which is going to be very similar to this one. First, let's go ahead and add one more NuGet package. We're going to be adding Dapper. Dapper is an amazing library that we can use to complement NAD framework. And we're going to see how we can combine them to achieve the same behavior that we had all along. I'm going to copy over the endpoint that uses the SQL update statement. I'm going to update the route. And now I want to change this part that executes our update command. So in order to be able to use this with Dapper, I'm going to say dbcontext.database, and I need to fetch the database connection somehow. And I can do this using the getDBConnection method on the database instance. And now I have access to Dapper specific methods. The one I want to use is execute-async, which is perfect for an update statement. And we're going to go ahead and write the same SQL as we did before. So update employee, we're going to set the salary to whatever it was before times 1.1. And I'm going to add a where statement. Now notice this time that it's a little different. Dapper uses placeholders as arguments. And now I need to specify my arguments as a separate parameter. So I'm going to create an anonymous object, which will have a company ID property, which will be the company.id of the company that we already fetched from the database. And these two property names have to match for everything to be working correctly. Now, Dapper will not run in the same transaction that NAD framework is implicitly using. So we have a similar problem that we had from our previous endpoint, and we solved that one using transactions. So we already have our transaction here. It's started and committed after we apply all the updates. The one thing that we need to do is to tell Dapper to use our transaction that we already created. Begin transaction actually returns a transaction object. So we're going to add a variable to capture it. And to pass a transaction to Dapper, we need to use transaction and call the getDBTransaction method, which will return the proper object that Dapper is expecting. And now that we have this in place, everything will function the same as in the previous two endpoints. I'm going to go ahead and add a breakpoint again, start the application, and we want to try out and see how this is working. So we jump over to Postman and we call our endpoint. We hit our breakpoint, we fetch the company from the database, and we stop at our update statement, this time using Dapper. So let's jump on over to SQL Server. Notice that the salary is 161. And after we execute our update with Dapper and hop back over to SQL Server, notice that the salary remains unchanged. So it seems like it's working. Let's continue on and see what happens. After calling save changes and committing the transaction, we can see that it really is applied in the database only after committing the transaction. Now I want to briefly talk about performance. We're going to call the first endpoint. It completes in around 250 milliseconds, which is not that great, but remember that NAD framework is creating 1001 update statements for this endpoint. Now let's check the performance of our second endpoint that's using SQL for updating the database. And as you can see, it's much faster. It completes in just 25 milliseconds, which is absolutely great. We are basically increasing the performance by 10 times by just using the proper tool for the job, which in this case is SQL. And let's also take a look at the last endpoint that's using Dapper instead of calling SQL from NAD framework. And as you can see, it completes in about 21 milliseconds. So it's just slightly faster. Now, Dapper is in general always more performant than SQL Server, which is why we see this slight performance improvement. But you have to ask yourself, is it really worth it to introduce Dapper to only gain a slight performance improvement, but you have an increase in complexity because now you have to manually take care of creating the transaction and making sure that you specify it when calling the methods that Dapper exposes. So that's just something to consider. We saw how we can perform one-to-many updates using NAD framework. We then saw how we can optimize on this using a SQL update statement. And in the last example, we introduced Dapper for executing our SQL update to gain a slight performance improvement. If you like this video, make sure to give it a like and also consider subscribing to the channel so that you don't miss any of my future videos. Until next time, stay awesome.